So here this experiment is emissivity apparatus. So here in this we are going to determine the emissivity of given grey body surface. So here you can see that we have been having grey body surface and the black body surface. With help of these things we are going to find out the emissivity. Emissivity of a surface is defined as a ratio of the radiation emitted by the test surface to the black body surface at a given temperature and is measure of how closely a test surface approximates a black body. Black body is an ideal surface which absorbs and emits the entire radiation incident on it. However, other surfaces like polished or glassy may not emit radiation as much as black body. Emissivity lies between 0 and 1 for the grey body surface. The emissivity of the grey surface is not constant, it varies with temperature, wavelength and direction of emitted radiation. So now let us see the experimental setup, what are the things we have been having. So here in this experimental setups we have been having two circular plates, one is the black surface you can see and another one is a grey surface. The black body is made up of copper with a black surface and mounted on the asbestos cement sheet. The grey surface is also of same material with polished surface mounted on the asbestos cement sheet. Heaters are provided at both the plates. The plates are kept inside the rectangular enclosure. The temperature of plate is measured by the thermocouples. Separate wires are connected to diametrically opposite points to get the average surface temperature of the plate. Another thermocouple is kept in the closure to read the ambient temperature of the enclosure. Digital voltmeter ammeter provided to measure the heat input given to the plate. So here whatever you can see that thermocouples attached, so they have been connected within a wire. We could not able to see on the surfaces the thermocouples. Okay, but these have been connected with this connection to find out in the indicators what are the temperature at the surfaces and the ambient. So we have been having here two heaters, heater 1 knob and heater 2 knob. So when you are going to on this heater 1, the heat is being supplied to the grey body. When you are going to on the heater number 2, so that is being supplied to the black body. So for this heater 1, that is for a grey body, we have been having a regulator here, and for heater 2 we have been having a regulator here. So we are going to supply a constant current so that constant temperature will be maintained. So once the constant temperature is being maintained, then we are going to identify the value of the value from the ammeter and the voltmeter. So after this we are going to understand how the procedure is being carried out. So we are going to switch on the black body heater and adjust for suitable heat input using the regulator. Then we are going to switch on the grey body heater and adjust the heat input same as that of a black body. Wait for a few minutes to reach the steady state temperature. Then note on the voltmeter, ammeter and temperature readings and repeat the experiment for the different heat input to the black body. So now we will go through the tabular column and calculation how we need to find it out. Now we have been having a tabular column. So in this tabular column we have been divided into grey body and the black body. Here you can see that whatever the voltage we have been going to note down in the grey body, that we have been noting down here in the voltage and the ammeter. The same thing here also we have been finding out, and whatever the surface temperature it is T2, T3, T4, it is been respect to the grey body, and for the black body it is T5, T6, T7. So those you can take the readings from the indicator. Then we have been having to find out the room temperature and the enclosure temperature. Now we will find out what are the things we have been having the equations to find out. Here we have been having the diameter of the black body, that is 120 mm, and diameter of the grey body. So both the things we have been taken a same diameter. Then emissivity of the black body, it is being considered as a 1, and Stephen-Boltzmann constant, that is a constant value we have been having, that you can see it here in this observation. Now we will going to find out. So the heat input to the black body in the watts, you know the value of the voltage and you know the value of the I, that is the current. When you are going to multiply, we can find out the heat input. Then from this energy balance, heat input to the black body is equal to the heat radiated from the black body. So here whatever the heat absorbed from the black body is being equal to the heat radiated from the black body. So we have been having this equation where the emissivity and Stephen Boltzmann constant and the area and the temperature differences, where AB is the surface area of the black body and TB is a black body surface temperature, that is the average we are going to take, that is been in the Kelvin, and TA is the ambient temperature in degree Kelvin, so that we are going to note down. In the same manner, the heat input to the gray body, that is been also we can find out within the same form of multiplication of voltage into current, okay, where V is the voltage and I is the current. From the energy balance, the heat input to the gray body is equal to the heat radiated from the gray body. So we have been having this equation where Ag is the surface area of the gray body, and this one emissivity with respect to gray body is this has been represented with this symbol, and Tg, that is the temperature of the gray body, surface temperature average, that is in a degree Kelvin. So from the equation of heat radiated from the black body and the gray body, the emissivity of the gray body surface is calculated with respect to the emissivity of the gray body and with respect to the black body. So then you will be getting the emissivity. So that is the thing we are going to write down. So this will be in the range of 0 to 1.